We are going to do the numericals of Hess's law. As we know, according to Hess's law, if we take a single step reaction or make a same product by many step reaction, we know that the enthalpy chain remains same. For example, question is asked that find heat of reaction, that is carbon solid plus oxygen, that is gas, we know that, and carbon dioxide product. Calculate the delta H for this reaction. And the enthalpy change of two reactions is given to you. First reaction is carbon, that is solid, plus half O2 forming carbon monoxide gas. Delta H for this reaction is, for example, minus X, any value. Minus X kilojoule per mole is given to you. This is equation number 1. And another equation is, for example, carbon monoxide is burning in the presence of oxygen, half mole of oxygen gas, and producing carbon dioxide gas. Now you can see carbon dioxide gas is formed, but in a two-step. First, that solid carbon is converted into carbon monoxide, then monoxide again reacted with the half mole of oxygen and forming carbon dioxide. Delta H, for example, for this reaction is minus Y. Information of these two reactions is given. Enthalpy change for these two reactions, heat content of these two reactions is given, and they ask about this third equation. Calculate the enthalpy change for this third equation. So you have to observe that which reactant and products are involved in this. First, you can see the reactant is carbon, that is solid. So that carbon is present in this first equation. Second, oxygen. Oxygen is present in both the equations, but as a 1 mole. And you can see here there are half moles. And carbon dioxide. The excess thing in both the reactions is carbon monoxide. What is carbon monoxide? So these are excess in this equation. If these two will remove from the both of the equation, then you are able to get this equation. Clear? So if you add both the equations, you will get your required product. To get the required equation, to get the required reaction, you can add the equations, you can multiply the equations, you can subtract the equations. It's up to you that what you want to do to get your required equation. Anything you can do. You can add, you can subtract, you can multiply. But in the end, you need to get your required equation. And your required equation is this one. You want to calculate the enthalpy for this reaction. As we know, if the two values are written with the is equals to like this, 2 is equals to 4. If I want to move this value of 2, when this 2 will move on the other side of equation, it will be minus 2. Am I correct? It will be minus 2. In a same way, in a chemical equation, if you are moving one value on the other side of equation, it will be in a minus. It will be in a minus. So, if I am going to add both the equations, now I am going to add these equations. Let's start the addition. here you can see carbon is written, so just there is one carbon in a reactant, so I have written carbon, that is solid. Next thing, oxygen. There you can see here is the half mole of oxygen here and half mole of oxygen here, so you have to add both the oxygen. So now you can write 1 mole of oxygen. Clear? Next you have carbon monoxide here and carbon monoxide in the product. If I will move this carbon monoxide on the other side of equation, it will be in a minus. So due to that, I can cancel these both carbon monoxide, because one is considered as a positive and other one is considered as a negative. Clear? Then both of them will cancel out, because we have to add the reactants on the one side and products on the other side. So if you are moving this carbon monoxide on this side, then it will be in a minus, or if you are moving this carbon monoxide on this side, then this will be in a minus. So in both the cases, both values will be cancel out. Clear? So both carbon monoxide will cancel out. Now arrow of the equation, in a product now carbon monoxide is left, so write carbon dioxide, not carbon monoxide. Carbon dioxide is left as a gas. Carbon dioxide gas. This is also a gas. Okay. So can you see that this is your required equation? Here you need carbon solid, oxygen's 1 mole and 1 mole of carbon dioxide. Here you have formed your required reaction, your required equation. Along with this, you have to add the enthalpies. We are adding the equations, then their enthalpies will also be added. So if you are going to add these enthalpies, you can directly add here, or you can separately write it like this: delta H is equals to delta H1, consider this 1 and 2, plus delta H2. So delta H1 is, for example, minus X, then plus delta H2 is minus Y. So minus X plus minus minus Y. So minus minus plus, both values of X and Y will be added, but the sign should be written for the bigger value. For example, if X is the higher value, the larger value, so you have to write minus. Clear? In obvious, the both value having a minus in this, but there are some reaction in which one of the value is in a positive. So you have to choose that value which is in a negative, which is having a higher value, not negative. So this is the basic concept about Hess's law, that how you are going to do. Next, giving you another example before doing question number 16. Okay, if in a exam question is asked about calculate the enthalpy change for Fe2O3, this is basically the rust, plus CO, carbon monoxide. If you are minusing the equation, then enthalpies will also be minus. Let's see, we are doing the example, you will better understand. In a problem number 17, you will completely get the concept of Hess's law. Initially, I am just giving you the general concept. Let's see, if in the exam they ask about delta H of a reaction, this reaction, you have to calculate the delta H for this reaction. Fe2O3 plus carbon monoxide plus ferrous oxide plus carbon dioxide. You have to calculate the delta H for this reaction. Clear? You have to calculate delta H for this reaction. Two equations are given to you. First equation is Fe2O3 plus 3CO. Product is 2Fe plus 3CO2 carbon dioxide. Delta H for this reaction, for example, delta H for this reaction is given as minus 26 kilojoules. For example, we are just supposing the enthalpy is okay. Next reaction is FeO plus CO. Product is Fe iron plus carbon dioxide. Enthalpy change for this reaction is delta H, for example, minus 16 kilojoules. Okay? So, what you can do with these two equations to get your required equation? First, you have to see which reactants in an equation are present and which products in a reaction. So, you can see this is your reactant. This is your reactant, but as a 1 mole, not if you add these two equations you will see 3 plus 1 will be 4, but you just need 1 mole. So that is clear that these two equations will not be added. These equations should be minus, then you will get your required reactant. See, you need FeO. FeO is present in the reactant side. You need to move it on the product side. So if this is in a minus, then you will get this in the product side. Second thing is 1 mole of carbon dioxide, and if you are adding these two equations you will get 4 moles, but you just need 1 mole. So no need to add the equation, you have to subtract. You have to subtract these equations. You have to subtract equation number 2 from equation number 1. Another thing, you don't need iron as a solid. You don't need this. So here you can see there are 2 moles of iron and here 1 mole. So you have to make it 2 moles to cancel both the values. So it is clear that you have to subtract the equation number 2 from the equation number 1, because you have to cross these values, cancel out these values, and you have to subtract the number of moles of carbon monoxide to get your required equation, or you have to subtract the carbon dioxide mole to get the required mole of carbon dioxide in a required equation. If you are subtracting, so you can see 3 minus 1 will give you 2 moles of carbon dioxide, or 3 minus 1 will give you 2 moles of carbon monoxide, but you just need 1 mole. So these all things clear your mind that you have to multiply this second equation with a specific number. So which specific number you need to multiply this equation? Which specific number you need to, here is also 2, then it will be cleared. Okay, so what specific number do you need? Manal having a question? Beta, what is your question, Manal? Ask. No question? Okay, continue. So we need a number 2. If you multiply this equation with the number 2, let's see what happened. I'm multiplying this equation with the number 2. So 2FeO plus 2CO will give you 2Fe plus 2CO2. If you are multiplying the equation, then enthalpy will also be multiplied. So enthalpy is minus 16. You have to multiply this with the 2. So 16 to the 32. So now new enthalpy is minus 32 kilojoules. Clear? If you are multiplying the equation, you also multiply the enthalpy. So now subtract the equation 2. Now this is equation 2. This is your new equation. This will not be considered now, because now you get the multiplied equation. So now ignore this one. Okay? You have to now subtract these two equations. Subtract equation number 2 from equation number 1. When you are subtracting, sign will change. But when you are adding, there is no change in a sign. So you are subtracting this. Minus, minus, minus here, minus here. What will happen with this? This minus of reaction will be opposite as a plus. Why this is plus? Let me show you. Delta H, this one, this delta H, second one, the delta H for this reaction, having a value in minus 32. And while subtracting, here if I am writing minus, so minus minus will be plus. That's why I am directly writing minus. All the time I will do minus minus plus. So don't waste time, just directly change the sign of the second equation. So minus minus is plus, so I have directly writing plus. First enthalpy is in a minus, now second enthalpy is in a plus. So minus plus will be minus. So you have to subtract the values because of the multiplication of the sign, as minus plus is minus. But write the sign of the bigger value in a result. Well, I will do this in an example of question number 17, then you will clearly get this. Let's do the subtraction of these two equations. Okay, I'm subtracting. Here is in a plus and no other same reactant is present like this. So you have to write Fe2O3. Next is 3 moles of carbon dioxide and 2 moles carbon monoxide and 2 moles of carbon monoxide in minus. So plus minus minus, you are minusing them. So it will give you 1 mole of carbon monoxide. Now here you can see FeO is in a minus and no any other same reactant or product is present. So this is in a minus. On the other side of equation it will be in a plus. So move it on the other side of equation because this is in a minus. As you know, no equation is written as a minus sign. So you have to move it. If you move the minus value on the other side, it will be positive. So you have to write here 2 moles of FeO. Now let's move towards the product side. These both will be cancelled out because one is in a positive with a positive sign and other one is with a negative sign. So both will cancel out. Move towards carbon dioxide, 3 moles of carbon dioxide and with the minus sign 2 moles of carbon dioxide. So you have to subtract. It will give you 1 mole of carbon dioxide. Now you can see this is your required equation. Clear? This is your required equation. Now subtract the enthalpies. Same. Minus 26 plus 32, minus plus minus, so minus 32 minus 26, calculate which, for example it is x with the positive sign because 32 is a bigger value than 26 and 32 having a positive sign. So delta H will be with the positive sign, positive x. These are the general concept. Now we are going to do our book's question, that is question number 16. Let's start. Question number 16. In a question number 16, you just have to add the enthalpies. In a question number 17, we are basically going to do the proper Hess's laws numerical. Let's start. By applying Hess's law, calculate the enthalpy change for the formation of an aqueous solution of NH4Cl from NH3 gas and HCl gas. Basically, delta H we have to calculate for the reaction in which ammonia gas is reacting with hydrochloric gas and giving you ammonium chloride aqueous. This is the requirement. 3 equations, 3 reactions are given in your book. First one is NH3 as a gas convert into NH3 as a aqueous with the enthalpy change of minus 35.16 kilojoule per mole. Second equation is HCl gas convert into HCl aqueous. Enthalpy change is minus 72.41 kilojoule per mole. This amount of energy will release when gaseous hydrogen chloride convert into aqueous. Equation number 3. Aqueous ammonia, because now they are converted into aqueous. So aqueous ammonia plus aqueous HCl reacting with each other and producing aqueous ammonium chloride, NH4Cl aqueous. Enthalpy change is minus 51.48 kilojoule per mole. 3 reactions are given. Enthalpies of 3 of the reactions are given. They ask you the enthalpy change when the gaseous ammonia and gaseous hydrochloric acid are reacting and producing aqueous ammonium chloride. So you can see in a first and a second equation, gaseous ammonia and gaseous chloride are first converting into aqueous, and then these aqueous are reacting together and producing aqueous ammonium chloride. So basically, if you recall the Hess's law, the product is formed in a single step or in a multiple step having a same enthalpy change. So if you want to calculate the enthalpy that is moving by the many routes, that is moving by the many paths, so you have to add all the enthalpies. So basically we have to add all these enthalpies in this specific question. So consider this is delta H1, delta H2, delta H3. So delta H is equals to delta H1 plus delta H2 plus delta H3. Delta H1 is minus 35.1 plus delta H2 is minus 72.41 plus delta H3 is minus 51.48. Basically all will be as a minus. Plus minus minus plus minus minus, all the sign will be with a minus, so you have to minus these all and your answer will be minus 159.05 kilojoule per mole. This is the answer for question number 16 for this specific reaction. Next, move towards question number 17. In this question number 17 you are getting all the concepts that I have given you in a start of the lecture. Let's start. Calculate the heat of formation. You have to calculate the heat of formation of ethyl alcohol. Formation of ethyl alcohol. Ethyl alcohol having a formula C2H5OH. In exam, the formula is not given. You have to know, you have to learn the formulas. So ethyl alcohol having this formula. So heat of formation for this formula, for this compound you have to calculate. Delta HF you have to calculate for this reaction. This is the formation. Heat of formation. How you can make it reactants? Make its reaction. How? Heat of formation is basically that amount of heat in which product is formed from its elements. So how many elements are there? Carbon, hydrogen and oxygen. So carbon plus hydrogen plus oxygen. So you know that hydrogen do not exist as a single atom. So it's confirmed that it will be in a form of molecule. Oxygen do not exist as an atom. So oxygen is also present as a molecule. Carbon can exist as a single atom. So you can write carbon. Okay, now balance the equation. 2 atoms of carbon, write 2 here. How many hydrogens? 5 plus 1, 6. Here you can see 2, write here 3. 3 2s are 6. Oxygen, here you can see only 1 oxygen, but in your reactant there are 2. So you have to write here half, because you need half. This 2 will be cancelled out with this 2. It is just 1 atom of oxygen. So you have to write here half. Okay, let's move Three statements are given. Heat of combustion of ethyl alcohol is delta H of ethyl alcohol's combustion is minus 136 kilojoule per mole. So they are saying in equation number 1, ethyl alcohol, that is C2H5OH, is combustion of this reactant is happening. Combustion takes place in presence of oxygen. It is confirmed that combustion reaction is the burning reaction in the presence of oxygen. So if ethyl alcohol is burning in the presence of oxygen, so the sole products will be carbon dioxide plus water. So you have to write directly. Second equation is heat of formation of carbon dioxide. So heat of formation, not combustion. So how carbon dioxide can form? By their elements. So elements are carbon and oxygen to form carbon dioxide. So you directly write here. Enthalpy change is given, that is minus 3. We have to balance the first equation. Let's just write 3 equations, then we are going to balance this. Okay, enthalpy change is minus 394 kilojoules per mole. After 5 minutes, this meeting will be ended. So let's do it quickly. Third one is the heat of formation of water. So how water will be formed? By its elements. So here you can see only one oxygen atom is needed. So you have to write here half. Balance the equation number 1. Here you can see 2 carbon atom. In a product there is just 1. So you have to write here 2. How many number of hydrogens? 6. So here you can see only 2. So you write here 3. 3 2s are 6. Here how many oxygen? 2 2s are 4 or 3 7. Or here you can see 1 and 2. So how you can balance this? In a product you can see 3 and 4, 7 oxygens, and in a reactant there are 2 and 3, only 3. So you have to write here 3. 3 2s are 6 plus 1. So now both sides having a 7 oxygen. Enthalpy change for this is minus 285.8 kilojoule per mole. All the enthalpies are given, all the equations are set. Now see these 3 equations and focus that which equations should be added and which equation should be minused. Let's see. You need a carbon, you need hydrogen, oxygen. This equation having a hydrogen, carbon and oxygens, and you need ethyl alcohol on the product side. Let's see, in equation number 1, ethyl alcohol is present in a reactant side, but you need this in a product side. So what you can do, if this is with a minus sign, then you can move this ethyl alcohol on the product side. So this proves that you have to subtract this equation. If you subtract this equation, then this ethyl alcohol will move on the product side. So add equation number 2 and 3 and subtract the result of these equations with the equation number 1. Let's see. First you have to add equation number 2 and equation number 3 because you need ethyl alcohol on the product side. So that proves you have to subtract the equation number 1. You can't add the equation number 1 because you need this ethyl alcohol on the product side. So let's add these 2 equations. Equation number 2 and equation number 3. Before the addition of these 2 equations, see in the required equation 2 atoms of carbon, 2 moles of carbon and 3 moles of hydrogen gas. But in your equations, in your reaction, there are 1 mole of hydrogen and 1 mole of carbon. So what you have to do? You have to multiply this equation with the 2 and multiply this equation with the 3. Let's do it. I am multiplying equation number 2 first with the 2. Let's do 2 carbon plus 2 oxygen will give you 2 carbon dioxide. Also add enthalpy. Enthalpy is minus 394. Multiply it with the 2. It will gives you minus 88 kilojoule per mole. Second equation, you have to multiply with the 3. So 3H2 plus 3 by 2 O2 give you 3H2O. How 3 by 2 comes? Because here in the previous equation, you know their half is written. Half O2. So if you are multiplying with the 3, it will be 3 by 2. 2 will cancel with the 2 and 3 remains. Okay, now add the equation. Its enthalpy will also be multiplied with the 3. Delta H is minus 285.8 multiplied with the 3. Okay, let's add these equations. 2 carbon plus 3 moles of hydrogen, add this one and this one, oxygen. It will be equals to 7 by 2. 7 by 2 moles of oxygen. Add this 2 mole of, this is a product now, 2 mole of carbon dioxide plus 3 moles of water. Now add the enthalpies also. Minus 788 minus 857. Also add these enthalpies. Okay, how this comes? ये कैसे आया है? Here you can see 3 by 2 oxygen plus 2 by 1 oxygen. So this is a simple mathematics. 3 by 2 plus 2 by 1. 1 3s are 3 plus 2 2s are 4. Numerators will be multiplied. 2 ones are 2. So 4 plus 3 will be equals to 7. 7 by 2. That's why I have written here 7 by 2O. This is the equation which is added. Add the enthalpies also. Next, you have to subtract the equation number 3 from this equation. 2 carbon plus 7 by 2